Alright, section D, limits of a quotient of polynomials. So the limit as x approaches infinity of p of x over q of x, where they're both polynomials, then we use the theorem that limit as x approaches infinity of 1 over x equals 0. So here's an example. So example 18, we have the limit of x approaches infinity of 3 minus x over 4 plus x squared. So we have two polynomial functions, which equals the limit as x approaches infinity, then we divide it by the highest degree, which in this case is x squared. So we take everything and divide it by x squared, simplify, and then we solve. So that way we get all of this equaling to 0. Alright, so now we have example 21. So in this we're going to explain the rational theorem function, which explains the asymptotes that we're going to see with these differing polynomial functions. So the first one that we'll see is number 1, where if both of them, or if the denominator's power is greater than the numerator's power, then the limit will equal 0. In this case, y equals 0. The next one, which is number 3, is when the limit as x approaches infinity and the numerator and denominator's higher power are the same, then we take the coefficients. So in this case we have 1x to the first power, and then in the denominator we have 5x to the first power. So then we take the coefficients, which is 1 over 5. Thus the asymptote lies where y equals 1 over 5 for this particular graph. Then we have the limit as x approaches infinity of x cubed plus 1 over 2 minus x squared. So right here we have the numerator's power is higher than the denominator's power, so that means that it's going to equal infinity. In order to find the sign, what we do is we find the denominator's highest power, which is x squared, and divide everything by x squared and simplify. So now we have this as our simplified limit, and then we solve by substituting it in. So we have infinity plus 0 over 0 minus 1. So we have infinity over minus 1, which equals negative infinity, and that ends section D.